Welcome back to UGC Swayam MOOC on biostatistics and mathematical biology. So let us continue the first module. The module is called Introduction to the Biostatistics and Mathematical Biology. Now here this is section number 2 called Critical Thinking. In our last section we discussed about the introduction, scope and philosophical framework. In this module we will be seeing about the critical thinking. Introduction is the critical thinking deals with the objective analysis of the facts to form the judgment. So it's a part of a decision making process or to form the judgment, right? So how to analyze the analysis of the objectively, right? So how do you do the objective analysis of the facts? So you have to take out the facts from non-facts. So how to actually choose the facts out and how to objectively, not subjectively, but objectively analysis it, right? Analysis of those facts objectively. That is called the critical thinking, right? The things that skew our judgment. So our judgments are known to have skewed by different influencing biases. So this includes emotion, cognitive biases, logical fallacies, mental heuristics and psychological effects. So we will be elaborating that. The first thing is cognitive biases. What is cognitive bias? So it is erroneous evaluation, reasoning or remembering or other cognitive processes often occurring as a result of holding on to one's preconceived notions, emotions, preferences and beliefs regardless of the information on contrary. So if you have some belief or a preconceived notions and you cannot actually change or learn despite a lot of evidences on contrary, those are called cognitive biases. One simple example is of the cognitive bias is confirmation bias. So confirmation bias is a tendency to interpret, record or search for or favor new pieces of evidence or information in a way that confirms one's pre-existing beliefs or hypothesis. One simple example is that if you are a vegetarian, chances are high that you are going to read articles that bolster why vegetarianism is good for example, health-wise or good for the world at large. It's more ecological, eco-friendly attribute. Or if you're a non-vegetarian, chances are high that you are going to look up stories and articles that confirms your preconceived notion that the vegetarianism is good. That, for example, human beings are, if you look at the anthropological evidence or archaeological or paleontological evidence that earlier human beings were non-vegetarian, for example, or non-vegetarian is good for protein, as a source of protein, for those kind of things. So it's nothing to do with is vegetarian or non-vegetarian is better, but the problem here is that you try to read sources, news sources or media or articles that confirms your preconceived notions. So that is the problem with the confirmation bias. Another example will be in biological taxonomy and classification. For example, archaebacteriologist Carl Woese. So Carl Woese was an archaebacteriologist. That means that he was working with archaebacteria. It's a kind of a bacteria, right? So he elevated that archaebacteria from mere monera, it was a kingdom, to the super kingdom. It is something called division. Division is the all-encompassing topmost level on the biological classification. So because he was an archaebacteriologist, so Carl Woese elevated to the level of the division, right, for the domain, right, the domain, not division but the domain, the real top domain. Another example would be on the same taxonomy, Cavalier Smith. He was a protistology. He was working with protista, and protists are as you know, it's a eukaryotic cell. So he elevated the protista to a kingdom. That is yet another confirmation bias. As you can see that this biological taxonomy and classification do have this kind of cognitive biases. So Professor Cavalier Smith did not agree. He abolished the domains of the archaebacteriologist, right, the Carl Woese, and instead he elevated his pet taxa protists to the kingdoms, right? Out of 6, there are 2 kingdoms of the protists as per Cavalier Smith 6 kingdom scheme. Cherry picking, what is that? It's selectively picking pieces of evidence that confirms your pre-existing beliefs or expectations. So in a way, cherry picking is something like a confirmation bias. One example is that during the drug testing, a chemist deliberately chooses subjects in which the drug worked and conceals the subjects where the drug did not work, to increase the statistical significance. For example, if the drug worked in 8 out of 10, he simply said that he tried only 8 patients. So 2 patients where the drug did not work, he concealed that particular evidence. So that is something called the cherry picking. Cherry picking is of course a form of a scientific misconduct. So cherry picking is illegal and unethical practice. Another kind of bias is called positive results bias. Here in this bias, authors are more likely to submit and the publications are more likely to accept positive results rather than the negative results. So if you are coming up with a negative result, so it is highly unlikely to get it published. So more and more the researchers try not to publish the negative results. So even the publications do not favor to publish negative results. So this is actually a cognitive bias called positive results bias. So a lot of positive result which is being published doesn't mean that negative results are non-existent. So it's only merely because of the bias. So while reviewing the literature, you should know that this particular positive results bias, also called publication bias, is very, very important. It's highly prevailing, right? So it doesn't really mean that the prevalence of the positive results. So negative results are also equally likely. So another kinds of different kinds of biases include anthropocentrism, in which whole world is created for the human beings and the purpose of the universe is for the humanity. That is what the anthropocentrism is. Another one is optimism bias. Here, overestimating the likelihood of the positive outcomes. Hyperbolic discounting is it's prone for immediate gratification rather than the delayed gratification. So it's a preference for immediate gratification. I want it immediately than the delayed gratification. Status quo bias. So here it is a preference for the current state of affairs without regarding the future. It is just about the current state of affairs to continue it. Status quo. Negativity bias is that negative news will have more effect, more impact, more ramifications on us than the positive news. In addition, there are several logical fallacies too. Logical fallacies are a common errors in reasoning through the use of invalid or otherwise faulty reasoning or wrong moves in the construction of the argument that undermine the logic. So these are faulty reasoning that is involved with the argument. So it is part of the formal reasoning where some certain arguments are illogical. So that is what we call the logical fallacies. One simple example is that a Chinese scientist is saying, the quote here, Chinese traditional medicine is effective as all Chinese believes in them. All Chinese believes in the Chinese traditional medicine, so it is effective. Herbal remedies are safe and it is part of the Chinese tradition for thousands of years. So this statement suffers from at least 3 logical fallacies. The first logical fallacy is called argumentum ad populum. So most of these logical fallacies have got Latin Latin words. So this particular thing is in Latin, argumentum ad populum. That means appeal to widespread beliefs. It's also known as groupthink. Here, the argument is that the medicine is effective because widespread, because all Chinese believe in them, right? So that is why it's a ad populum logical fallacy. Another logical fallacy is that argumentum ad antiquatum, right? So antiquatum because it is appeal to tradition, so it's part of the traditional Chinese remedy. Another problem with this particular argument is dicto simpliciter, it generalizes. For example, herbal remedies are safe and have no side effects. So that is actually generalizing all herbal remedies. That means that all herbal remedies have no side effects. So that is a dicto simpliciter. Yet another logical fallacy is called argumentum ad verecundiam. So that means the appeal to authority. So authority said so that must be true. That is what you call argumentum ad verecundiam. So consider the following preposition. There are 6 kingdoms in biological classification as the world authority of taxonomy. Cavalier Smith from Oxford said so. So here, as you see, in science there are no authorities, right? So because one famous scientist said so, that doesn't mean that that particular argument is valid. So that is incorrect. Anybody can question. That is the beauty of science. So here it is argumentum ad verecundiam, because it's an appeal to the authority. It's a logical fallacy. Another one is called ignoratio elenchi. That means it's missing the point. For example, perpetrators of the pseudoscience formulations often claim that their remedies are government certified. So most of these kind of pseudoscientific remedies, they say it is government certified. What does that mean actually? Certifications are merely good manufacturing practices. That means GMP. What is being missed here is, however, these certifications have nothing to do with the efficacy of the remedy. So how effective the remedy is for that particular treatment, it's nothing to do. The certificates merely says that it has followed the quality control for that manufacturing of that one, right? So the certification is not an attestation to that the formulation works, or the formulation is effective, or the formulation is evidence-based. So that is not what it means, that particular certificate. That is why it's called ignoratio elenchi. Another logical fallacy is called argumentum ad hominem, or ad hominem fallacy. What is that? Ad hominem is personal attack. So instead of attacking the argument, you are attacking the proponent, whoever has actually put up that particular argument. One example is that the person who makes that claim is uneducated. So the claim must be false. So the person whoever is putting forth that particular scientific argument, just because of the fact that the person is uneducated, does not mean that the argument is fallacious, right? That is ad hominem fallacy. Yet another logical fallacy is called the false dichotomy. Here, while only two options are presented, there might be many intermediate options available. One simple example will be the species concept. Species A, species B. Doesn't mean that these two are non-contiguous, right? These are actually, there might be infinite number of subspecies inside each of these species. Or the same problem is with the language 2. Language 1 and language 2. Each language will have sub-language, also called dialects, right? So there is a fine gradation from one language to another language, especially the geographical neighbor. That is why it's a false dichotomy. If you think in philosophical terms, the dichotomy is false. Yet another logical fallacy is called slippery slope. In the slippery slope, it is a consequentialist argument, so that it pertains to the consequence of that particular action. So it is consequentialist. Logical fallacy in which the proponent argue a small initial action would necessitate a series of chain reactions, like in a dominoes or nuclear chain reactions, that culminate in a significant negative effect. That is what is actually being forth, right? Negative effect will be coming up. One example is that teaching evolution in school would make children believe that they are one among other animals. Countless number of animals is just one among different animals. So this would cause them to reconsider the morality. Finally, they would become immoral, right? So that kind of argument is what you call the slippery slope. So you should not teach evolution, because teaching evolution will make the children think they're animals, and they will practice what the other animals do. So that is actually consequentialist, that is slippery slope. In addition, there are so many psychological biases also. For example, heuristics. Heuristics are mental shortcuts. Availability heuristics is one simple example. While evaluating specific topic or concepts, our minds relies on immediate examples that come to our mind. So what are the immediate examples? For example, the example that I read yesterday in the paper, or day before yesterday, or the last week, it will come to my mind rather than something that happened 1 month back or 2 months back, right? One simple example is that which among the following is likely to cause death? Water sports, terrorism, or aircraft crashes. So aircraft crashes or terrorism, most probably you will be answering either of these, right? So because any kind of terrorist attack anywhere in the world is prominently being featured in the media, right? Television media, visual media, or the print media. So as aircraft crashes or the terrorism, right? But the problem is with this particular availability heuristics, that the water sports is number one amongst these three things, right? Though the water sports never comes in the picture, right? Because the media never actually prominently feature the stories of drowning. Hawthorne effect is yet another very important psychological biases. So subjects modify their behavior simply responds to the fact that they are being observed. So some subjects modify the part of behavior just because of the fact that they are actually under observation. Somebody is observing them, not in response to any particular experimental manipulation. So not really in response to any manipulation. There is a very famous example with a light intensity at a factory called Western Electric in the US. So the light intensity changed it. So they actually increased the light intensity to see the factory output. So the factory output were tremendously increased when they increased that light intensity. Then the investigators decreased the light intensity. Again they noticed the same effect, that the productivity tremendously increased again. So both the increase was significant. Increase in light intensity or decrease in light intensity caused it. It's nothing to do with the light intensity really. It has to do with it's just the fact that the subjects are under observation. So they are actually under observation. That is the reason for that particular thing. So what is bandwagon effect? People do things because other people's in a social circle does it. So if your peers and your friends are doing something, and chances are high that you will also do the same kind of stuff. One simple example would be that I use standard error in my graph. Why? Because all my colleagues use standard error over standard deviation. Everybody is using standard error, and that is why I'm using standard error in my graph. Or everybody in my subject is using standard error, and that is why I have to use standard error in my graph, not standard deviation. That is wrong. That is actually bandwagon effect. Another one is called anchoring. What is anchoring? Anchoring is the first thing that we judge influences our judgment of all that follows. So whatever the first thing that comes that in our mind that we judge will tremendously have effect on our next judgment. Whatever the judgment that we are doing that later. For example, a very high initial price set by the sellers is a common strategy during the negotiations. And now next one is called survivorship bias. So what is survivorship bias? Here investigators consider survivors alone, disregarding non-survivors. So non-survivors should also be taken in care in your study, right? You have to accommodate non-survivors too, rather than survivors alone. One simple example is that a famous study that concluded that cats falling from higher stories survive the fall much better than those cats that are falling from the lower story. So higher story like 6th floor and 7th floor, they survive better the fall than those falling from the 1st floor and 2nd floor. Quite unlikely, right? Why that particular study actually? Because the issue is that here the investigators concentrated only on the survivors, those reported by the vet. But here the problem is that non-survivors are omitted from the result. So instead of thinking, we can think that instead of survivors, these are something called injured cat. So cats are more likely to get injured if they fall from the top floor than the cats that fall from the bottom floor. The first or second floor. So that way, the reasoning becomes a lot more plausible, because on the 6th and 7th floor, chances are high that the cats cannot survive, and dead cats are not taken to the vet. Only surviving cats are taken to the vet. So that is why it's a survivorship bias. Other kinds of biases include social desirability bias. So the respondents, especially for the questionnaire survey, are likely to answer questions in a way that affirms the actions that are generally considered acceptable to the established social norms. One simple example is that the questionnaire survey that's asking for how often do you lie. As you know, the lie is considered to be kind of a social stigma. It's not a desirable attribute, and the respondents of that particular survey are highly likely to say that they lie less often. So they are under-reporting the frequency of their lies, right? So that is why it's a social desirability bias implied. Another example is that placebo effect. So in the case of placebo effect, which is a psychological effect, the result that results from the belief that one has been treated rather than having experienced the actual changes due to the physical, physiological or chemical activities of the treatment. So the treatment as such do not have any active moieties, so there is no chemical or physical or physiological response. So but this one is a purely psychological effect that the patient is undergoing some medication. So it is purely a psychological effect. One simple example is that the doctor is disbursing an unlabeled tablet from its cabinet informing the patients that the tablet is some arcane new generation therapeutic, while in reality the tablet is nothing but a multivitamin or something of similar, devoid of the active moiety. So even if the doctors disperse a multivitamin in unlabeled box or unlabeled tablet, the patients might think that it is actually something a next generation antibiotic or a chemotherapeutic, and you might even see a significant change or improvement in the disease outcome. So that is all because of the placebo effect. Yet the two rather informal fallacies are straw man fallacy and Texas sharpshooter fallacy. What are these? Straw man fallacy is that instead of attacking or refuting the main argument or a problem, the proponent construct an unrelated, often superficially similar argument or a problem and refute it. So instead of attacking the real the problem or argument, you construct a similar argument and then you attack it. It's a straw man. You construct a straw man and then you attack the straw man. That is called a straw man fallacy, right? One example will be anti-vaccination group or the camps that say, you don't care about autistic children. As you don't care about autistic children, vaccines are bad. So you're saying that vaccine group do not care about autistic children and therefore they are bad. So there is an implicit assumption that the vaccine causes autism, which is totally wrong. It is totally disproven attribute. So they take that particular assumption, then they attack that particular straw man by the autism. That is why you are wrong, because that vaccines cause autism, right? Another kind of informal fallacy is called Texas sharpshooter fallacy. What is that? So when the difference in the data are ignored but similarities are stressed, so it is a kind of a statistical clustering. The name Texas sharpshooter fallacy derived from a cowboy in Texas in the United States. He randomly shot the bullets onto his barn, and as you see, there is multiple bullets will come up, right? The bullet holes will come up. So by looking at that bullet holes, so certain holes will be clustered together. So looking at those holes, he drawn one kind of like a bull's eye, so that you are thinking that he's claiming that I've been shooting right on that eye of that particular bull. It's a kind of a hindsight bias, which is also related to the Texas sharpshooter fallacy. One simple example is that in the statistical test, so you change that your p-value, right? After you get your experiment is done, you change your significance level or threshold p-value, which is actually totally wrong practice. It's a scientific misconduct. But you do that with a hindsight, I know that what will happen, so I should actually change that, so I should decrease the significance level. That is a kind of a Texas sharpshooter fallacy. So there's a very famous statement by James L. Mills, a famous statistician, and he said that in the fishing expedition catches a boat, if the fishing expedition catches a boat, the fisherman should throw it back and not claim that they were fishing for the boats. So if you're getting a boat in the fishing expedition, don't say that you were actually went for the boat expedition. After all, it's a fishing expedition, right? So you should throw it back and do not claim that way. So that is exactly because of the Texas sharpshooter fallacy. So in summary, some important biases are pertinent to the field of statistics are confirmation bias, cherry picking, positive results bias, argumentum ad populum, argumentum ad antiquatum, dicto simpliciter, false dichotomy, argumentum ad verecundium, ignoratio elenchi, availability heuristics, anchoring, social desirability syndrome, and Hawthorne effect, placebo effect, and so on. That we covered most of these important biases and heuristics and logical fallacies in this particular section. It is essential that the students of statistics be aware of these subconscious biases to make sure that their conclusions and judgments are not being affected by them. I hope you had a nice time in this particular subsection on critical thinking, and see you soon in the next section. Thank you.